Hello! In this video, I will be sharing my overall learning and experience from our feedback control laboratory subject, and specifically from the laboratory experiments that help me understand control systems, system behavior, stability, and MATLAB-based simulations. So throughout these laboratory reports, I learned that feedback control systems is not just about formulas and equations, and it is based on understanding how systems behave and how they respond to inputs and how engineers can improve systems performance using analysis and simulation tools. So in the first laboratory experiment, it introduced me to the control system toolbox in MATLAB. So during this activity, I learned that how different control systems can be connected using series, parallel, and feedback configurations. So these experiments help me understand how block diagrams are translated into mechanical or mathematical models and transfer functions. So in the second experiment, it focuses on the Simulink and Simscape on RAM training. So this activity introduced me to graphical system modeling instead of purely writing equations or codes. So I learned that Simulink provides a visual environment where engineers can simulate dynamic system using blocks, while Simscape allows physical systems to be modeled more realistically. So in the experiment 3, I learned one of the most important foundations of the feedback control system, which is the transfer function and time response of a system. So this experiment helped me understand how mathematical equations can represent systems behavior through transfer functions, and I learned how to derive transfer functions manually and verify them using MATLAB. And more importantly, I observed how system responds when subject to a step input. So I also became familiar with important performance measurements such as a rise time, peak time, settling time, and percent overshoot. So these parameters help me understand how engineers evaluate whether a system responds efficiently and accurately. So in the fourth experiment, it focuses on the system stability analysis, which it taught me how the location of poles and zeros determines whether a system is stable or unstable. And I learned that poles and zeros are important because they directly affect system behavior and response over time. So through pole zero plots, I observed the systems with poles on the left side on the complex plane tend to be stable, while poles on the right side may lead to instability. So the experiments also helped me to understand the relationship between mathematical theory and practical system performance by observing impulse responses and stability behavior. And I gained a clear understanding of why engineers must carefully design systems to avoid instability. So in the fifth experiment, it discusses the performance specification of second-order systems, which deepen my understanding of how damping and frequency affect system response. So in this activity, I learned how damping ratio influences oscillations, overshoot, and system stability. And I observed that increasing damping reduces oscillation and it creates smoother responses, while low damping causes stronger oscillatory behavior. And the experiment number 6, I learned about how root locus analysis and how controller gain affects system stability, and this activity showed me how poles move across the complex plane as the gain value changes. So one thing I found interesting was seeing how a system can transition from unstable to unstable. So to simply by adjusting the gain, through the MATLAB root locus plots, I understood how engineers predict systems behavior and determine the proper controller and to improve stability and performance. So in the experiment number 7, expanded my understanding of root locus through controller design. So in this activity, I learned how compensators and additional zeros can improve system performance to meet designed requirements. So I realized that not all the systems naturally satisfy performance specifications, so engineers use compensators to improve overshoot, settling time, and stability by using MATLAB, CISO tool, and I observe how adjusting zeros and gains changes systems response and helps meet desired specifications. And lastly, in laboratory experiment number 8, I learned that about PID controllers and how they improved system performance. I understood the difference between the proportional integral, proportional derivative, and the PID control systems. And what I learned from this experiment is that the controller gain always involves trade-offs. A faster system response may increase overshoot, while reducing overshoot may slow down the response. So through the MATLAB and SISO2 simulations, I realized that PID controllers greatly improve performance, but no controller can perfectly solve every limitations of a system.